Welcome. In this video I'm going to be taking a look at this ALLLIKE SN-1000 portable power station. So this was provided to me by the distributor, but they're not compensating me for this video and they're not reviewing it before I post it. If you find this video helpful and you want to purchase one of these, I'll put a link to it in the description on Amazon, and if you use that link it helps me out a little bit and doesn't cost you anything extra. So let's take a look at the back. So we have the specs here. You can pause and read through these. I'll cover a couple of them. So the battery type on this is lithium-ion NCA. So that's nickel, cobalt, aluminum oxide. The battery capacity is 48 amp hours. The battery power is 1037 watt hours. For cycle life, it says after 1,000 cycles, the battery capacity will decrease to 80%, and it can be stored for 6 months when fully charged. So we have some more specs over here. Input on this for AC charging is 500 watts. For solar charging, it's 120 watts. This has 2 AC outlets. Max power is 1000, although peak power is 1050. It has 2 fast charge USB ports, has 2 fast charge USB-C ports, and it has 2 DC 5521 12 volt ports. So this comes with the power station, ATX C13 cable, car charger, and instruction manual. So let's get this open. So this says some built-in handles here. I'm going to take the box off my bench and bring the battery up to it. There's the battery. Under the battery we have a box with the accessory cables and such. So that pushes out the bottom. So it has this like fabric around it to protect it in packaging. That feels nice. There we go. Let's get the cables out here. So here we have our car charger cable and our power cable. Back here, looks like we have our instruction manual. So this lists the different features. You can pause and read through that. This shows the display and the different things on the display. And then we have technical specs in the back. So let's look at this. It looks like we have a light, we have a vent, we have our AC outlets. Here we have our input for solar and AC. So this will open up. So you can see the ports there. Let's take a look at the bottom. We have rubber feet on here, and we have a label with some tech specs. On the top we have a rubber mat. Now this is not wireless charging. This is just a mat where you could place something like a phone or other device. So here we have a display, button for the light, power, USB-C DC, AC, and we have our 4 USB ports and 2 DC out ports. Let me pull the plastic off this screen here. There we go. So it feels like this is aluminum on the outside. It feels very solid here. Now this has some heft to it, but for 1,000 watt hours, it's really not terrible. Let me get a weight on it. So for a weight, I got 21.4 pounds. So let's try turning this on. I haven't read the manual in detail yet. I'll press power, so that's not going to turn it on. I'll hold the power down, and that turned it on. So that's good. So it might be a little difficult to see. There's a better look at the display. So the display went off. Let's turn that back on. Probably because we did not have a load on it. So it says we're at 28%, and then here it says input watts, output watts. So let's turn the AC on. So the AC kicked on. Now that kicked on the fans in it. Let's turn that off. So pressing AC turned the inverter on and off. Now to turn DC on or off, we'll press the power button again, and it turns the USB and DC on. Press that again, we turn it off. Let's hold that down. That turns the whole thing off. So let's try charging this. So I'll turn around to the back, plug in the power cord, plug that into power. Okay, so that turned the fan on, and I can definitely feel air coming out of here. We're currently drawing, looks like 430 watts. Let's look at the display, and the input watts on this is 375. So there are going to be losses between plugging it in and charging the battery. So I'm going to let this get charged up, and then we'll test it out. Okay, so I have this charged up. It's currently unplugged. I'm going to plug in this heater, and I have a smart device here that is an energy monitor, so I can monitor how much energy we used. So I'll plug that into the AC port, and here I have a heater. Now in the high mode, this is going to require more power than this can put out, so I'm going to try and switch it before it triggers the protection. So this will be a heavy load. So I'm going to turn on the power here. I'll turn on AC. So the fan is kicking on the inverter, and now I'm going to turn the heater on. And it is on low, so we're currently drawing 541 watts, and I'll show that in a second. And now it's bumped up to 864 watts. There we go. So we're running just under 900 watts, and it says we have 2 hours of runtime. So I'm going to let that run, and then I'll come back and we'll take a look at the results. Okay, so we had 5% of the battery left and the AC shut off. So that's likely a protection mode to protect the battery. Let's see if it will turn back on. So it beeped and it did not turn back on. Let's try USB DC. Okay, so that does turn on. So it looks like it could still be used for, say, charging a phone. So let's head over to the computer and check the numbers. Okay, so here we have the stats. So the heater was running for 58 minutes and 49 seconds, so it's just under an hour. The first stat here, we have the current consumption. So when we turned it on, it bumped up to a little over 900 watts, and then it settled around 850 or so. You can see it kind of tapers a little bit. Towards the end, it's at 846, and then right before it shuts off, it drops down to 820, right at 820 watts. So here's our current consumption. We start down here at 0 kilowatt hours, and then we end up at 0.83. So the capacity on this is 1037, and we got 830. Now this is 0.83 kilowatt, so to do watt hours, it would be 830. So if we take 830 divided by 1037, that gives us around 80% of the capacity we used. So with a portable power station, you're never going to get 100% efficiency. There are multiple things to consider. You have the inverter efficiency, and then also there's likely some reserve capacity on there because you don't want to run it completely all the way to 0. So under that we have voltage. So this is at 119.2 volts, and you can see this is very, very steady. Until the end, it drops down to 117.5, and that's when it kicked off. And here we have our current. So this shows the amps. So this will correlate with the watts. So looking at these numbers, this is what I would expect out of this, and everything looks good in my opinion. Okay, so I'm outside doing some work on my house, and I need to drill some hole in the masonry. So I have my rotary hammer, and I could drag out a long extension cord to get power to this location, but this is rated at 450 watts, so the ALLLIKE power station should easily be able to handle the power load on that. Now I do have some leaves kind of around here. I'm just drilling a hole or two. If I was doing more work, I'd get a little bit more area opened up around the power station. But the vents are above the leaves right now, so it should get some good ventilation. Okay, so I got those holes drilled. The power station worked great at powering the drill. So a lot of us have cordless tools, but for those tools that we don't have cordless, you can use a power station like this to potentially make them cordless. Just check out the watt rating of your tool and make sure it's within the range that the power station can handle. So here's another use for a portable power station like this. So I have this electric kettle here. This was provided to me for a previous video, but they have no association with this video. So this kettle draws between 300 and 400 watts. I filled it up with just over a cup of water, and it's at 59 degrees Fahrenheit. So I'll put the lid on here, and we'll plug this into the back of the power station. So you can imagine this could be in the back of your car or your SUV while you're camping. So I'll turn this on. I'll turn the AC inverter on, and now I'll turn the kettle on. So we're currently set to boil mode. So if we look down here, we're currently drawing 443 watts. Now it's 370, so this will even out at some point. So when I filled this up to capacity at 380 milliliters, it takes around 7 minutes to boil, but I have less water in now, so it shouldn't take quite as long to boil. So I'm going to speed this up until it's done boiling, and we'll see how much capacity we used on the battery. Okay, that's finished. So this was at 100% when we started, and then after boiling the water, we're at 97%. So this is a little over a cup of water. If I was camping, I'd likely use this to make my oatmeal in the morning, but this would work just as well to make coffee or tea or something else. This is a nice setup like this, in that it doesn't take a lot of equipment. You have the battery and the kettle, and you're also not dealing with fire, which is nice. So you could have this sitting on the back of the tailgate of your truck, or maybe in the back of your SUV. Needless to say, you want a stable surface for your kettle, but it's not taking up a lot of room to boil the water, and you can use boiled water for lots of different drinks and foods and such. Okay, so here I have the power station and my laptop, and I have a USB Type-C charging cord. So if we look at the specs here, for USB output, it says fast charge USB-C. Each port is 100 watts up to 20 volts. So it doesn't say power delivery, but 100 watts, 20 volts sounds like power delivery. So let's try this out. So I'm going to turn this on, and then I'm going to press the orange button again to enable the USB, and I'll plug into the USB Type-C port. And it currently says plugged in here, and now it says charging. So if we look at the power station, it's currently drawing around 60 watts, which makes sense because this charges at around 60 watts with this computer and cable. So charging in this fashion with the USB-C cable plugged directly into the power station is very efficient. You don't have as many losses as you do using a power brick and the inverter. You also don't need to turn the inverter on, so it's going to be a lot quieter charging directly with USB Type-C. So this power station does have this light on the back. So we have a couple of different modes. I have it pointed about 3-4 feet away from this corner. I'll turn the lights off and we'll see what that light looks like. So to turn the light on, I'm going to power on the power station. and I'll press the light button once. So that will turn the light on. So this is the low mode, this is medium, this is high. Now we do have some flashing lights coming up here. So this is the, I think, SOS mode, and then this is the flicker mode. I'll press it again and it turns it off. So let's turn that on high again. So when this is on high, the output on this is showing 2 watts, and it says it will run for 85 hours. Okay, so here I have the power station next to this freezer. This is a chest freezer. So I'll turn this on, and I'll turn on my AC. So this is something you might do if you have a power outage. Now this is going to cycle, and it's currently about 10:54 or so. So I'm going to let this run a bit. We're currently at 97%. I'll come back later, I'm not sure when, and we'll see how much power it used. This isn't a perfect or an exact test because different freezers will take different amounts of power. But that did just kick on, which is good, and it's currently drawing 93 watts. So well within the capabilities of this power station. So that will run a little bit, it will kick off, and it will just continue cycling like that. Now you could do a similar thing with the refrigerator. One thing to point out is refrigerators tend to have defrosting circuits, and those can take quite a bit more wattage. So a fridge might take 100 watts, the defroster might come on, it might take 700-800 watts. Now this power station could cover that, but what you'll want to do is look at your label and figure out how many watts max your appliance uses before you plug it in. Okay, so I'm back at the power station and I noticed it's off. I'm glad this is happening because it provides a good example. So this freezer doesn't have a continuous load, and I did check it about an hour ago and it was still on then, but this ended up turning itself off because it didn't think anything was connected. So let's turn it back on, and we're still at 97%. So in the 3 hours this has been on, it's probably run a couple times maybe. But if you're using it for something like a chest freezer, it's probably best to plug it in every couple hours, let it run. It'll get the freezer cooled back down, and then you can just turn it off, and maybe you take it somewhere else and plug it into a refrigerator or something. Let me turn that back on. Let me actually turn the AC on, and we'll let it run. You could alternatively put a second load on here that's smaller that would keep this active. But I think it makes more sense to just run it occasionally on a device like a chest freezer. And this is in a basement too, so this chest freezer could easily go a day without power and still keep everything in it frozen. But if you have an extended power outage, using something like this, you can run it every once in a while to make sure everything stays cold. So that's the ALLLIKE SN-1000 portable power station. I really like the compact size of this. It packs a lot of power into a small area, so there are many uses for a power station like this. I went over a couple in the video. Now this can be charged with solar. I am going to cover that in a separate video, and when I have that video out, I'll put a link below to it. So there are a lot of features I like with this. It's nice that it charges up with a standard size power cable. These are super common, so if you lose it, you can easily get another one, and you don't have to carry around a large transformer to charge this. And the cord it comes with is actually pretty short too. So you could get a longer one if needed, but I like this, it doesn't take up a lot of room. I like that this has 1,000 watts of power, so it can run quite a few things, like power tools, electric kettles, things like that. And it has that USB-C port, and then in my testing supported power delivery, so you can run things like laptops or fast charge phones. It also has the USB-A ports, so you can charge pretty much any USB device with this. Now it does have the DC out that are barrel jacks, so if you wanted to plug in something like a portable fridge, you would need an adapter to do that. Now some things to consider with this: when the inverter is on, the fan is on, and it does make some noise. So if you want something that's absolutely silent, this may not be the best option, but this is certainly quieter than something like a generator, which would be way, way louder. Now this is lithium NCA, and that technology packs a lot of energy into a small area. Other power stations will use lithium iron phosphate. There are pros and cons to each technology. The big pro of this is that you have a smaller form factor for the same amount of energy. Now one thing about lithium NCA is you'll probably want to keep this cooler in the summer and warmer in the winter than some other lithium technologies. So you probably wouldn't want this sitting in the direct sun on a hot day, and that's good advice for any type of lithium technology, but you'd probably want to put this in the shade. So if you have your solar panel in the sun, make sure this is tucked away in the shade somewhere. Even doing something like putting this under a chair could shade it. And then also when you're storing this, it's best not to store it at 100%, maybe take it down to 80, 90%, and then you don't want to leave it at 0 either. So if you drop this down to 0, you want to make sure you charge it up, because if you leave this or any other power station at 0 for a long period of time, that can damage the cells. Now, if you're comparing this to a gas generator, you have to do oil, gas, and all that to it. So with something like this, mostly you just need to pay attention to your state of charge on this and make sure you keep it in the middle when you're not using it. So that's all I'm going to cover in this video. If you have any questions, please leave them in the comments. If you like this video, please click like. If you haven't subscribed to my channel, I'd appreciate if you could do that. And thanks for watching. Until next time, goodbye.